Let's go into Module 3, leading to hypothesis testing. So before we start empirically testing our hypotheses, we want to understand what are the different types of analytics that we can use. The first two, descriptive and diagnostic, those largely fall under business intelligence. So you may use a tool or BI tool or software to develop descriptives or do some diagnostic analytics, employ some diagnostic analytics. But under descriptive, we might be able to figure out what happened, right? We might use some historical data and we would look at or be able to summarize overall profit, revenue, also maybe cost for a specific time period that has already occurred. That might be a summary report by day, week, month, or quarter. Well, under diagnostic, we could actually drill down a little bit further and figure out why it happened. Example there might be revenue and cost by categories, including product, service, location, if the business or organization has numerous locations, client or customer, or external factors such as the environment or time period. So again, that would fall under business intelligence. So you would be able to use a tool such as Tableau to maybe create a dashboard and summarize your overall performance, as well as drill down a little bit further to understand why that overall performance was what it was. Well, we might be in settings where we're needing to employ some more advanced techniques or use advanced analytics. And predictive and prescriptive would fall under more advanced techniques. So predictive, we'd be able to answer what will happen. So you might try to estimate profit or predict or forecast profit based on maybe the client or customer activity, external factors, also potentially revenue and cost patterns, also identified using historical data. Additionally, there's prescriptive, and that's where we're able to answer what should be done. So optimization techniques, for example, or optimization would fall under prescriptive analytics. Based on expected demand, for example, for a period in the future, we might be able to identify, using a prescriptive model, the best allocation or optimal allocation of resources that will directly impact our operating activities to, say, maximize a return, such as profit. Well, if we take a step back and think about how statistics sees it, when we think about business questions, when we employ statistics, which again may not always be the case that we're building or developing some fancy statistical model, there's really two categories: descriptive and inferential statistics. With descriptive, and you can tie this to the types of analytics, descriptive, we're describing the data as it is. In a descriptive setting, we're using all of the data, and we might do some basic summaries, including looking at the average or mean, the median or 50th percentile, the mode, the range of values, the variance, the standard deviation. So all those can be done with quantitative or numeric data. You might also, it's not listed there, but you might also do some frequencies as well if you have categorical data and look at the frequency that a certain category occurs for a field. So the purpose there is summarization and visualization. An example there might be the average home price in a geographic area. Inferential, we're trying to draw conclusions from the sample about a population. So in that setting, we're often using sample data, and we would use various statistical approaches, including a t-test, for example, in which we're evaluating whether an average value for one group is statistically significantly different than another group. We might use ANOVA, we might use regression, also we might develop confidence intervals. And again, I hinted at this in the last module, but there's always some sort of uncertainty, right? There's some sort of range of uncertainty, and that's where we're able to leverage statistics and understand what that uncertainty would look like around that estimate. The purpose there is prediction and hypothesis testing. And an example there would be a predictive model equation that we develop using data to estimate or predict the home price in areas, let's say based on square footage. Right? We might use other characteristics as well, including number of bedrooms and whether it has a garage and so on. But that is really the two categories of statistics, right? Descriptive and inferential. And you can again tie these back to the different types of analytics you might employ. Okay. So now we have an understanding of different types of analytics and the difference between descriptives and inferential statistics. We can think about the data itself, right? When we think about data sources, there's really two different types: primary and secondary. So primary is actually collected for a specific purpose. For example, we might do a survey to collect information on experiences, opinions, beliefs, and so on. Let's say we're collecting information on customer preferences based on certain product offerings. That would be a survey. In terms of experiments, that would be the second main type. We might try to measure the effects of some sort of intervention or treatment. For example, A/B testing is a common form of an experiment in marketing. So I might show customers or potential customers two different email offers, and then evaluate or record the impact on their response. And that would allow me maybe to see what is more effective or what is less effective based on those two different offers. The third main type of primary is observational studies. Those are very similar to experiments, but no treatments applied yet. So really just functioning as a fly on the wall, right? We're watching something. This could be done through video, it could be done in person, and we're going to routinely collect some data. An example there is we might look at customers and maybe where they go in the store, what product displays are more popular, where in store people are going. That might give us some insights on what their preferences are, what is effective, and so on in terms of displays and product offerings. So those are the three main types. There's more than these, but these are the three main forms of primary research that would lead to potentially a data set that we can then analyze and make sense of. So next is secondary, and that's largely data that's already collected as part of your regular operations, right? Internally any general records, transactions, or any other data that's captured as part of an organization's operations, including customer purchase history, product sales, customer service records, as well as outcomes. External examples would be any publicly available data, any pre-existing research or studies that have been done, including market research or customer demographic data that might be available for purchase, or third-party data. Also external might be any internet or social media data, so any social network that you can collect data from would be external as well, and secondary. But one of the other things that we need to think about is our data, suppose we've identified some data, whether it's primary, secondary, is it cross-sectional or is it longitudinal? So this actually may help us in terms of the relevance of the data to our business question or business problem, but also the techniques that we might employ. So with cross-sectional, that captures a single point in time. It is basically a snapshot, right? The focus is a snapshot, and you can think of this as a snapshot of variables that we're collecting at a single point in time. There's different subjects, or for example, let's translate this to layman's terms. There's different people in that data set. And the types of analysis we can do is descriptive or comparative. Obviously, the cost or the resources that we would need to expend is smaller for cross-sectional, right? We're only doing it once, really. We're capturing that data once. That would be in contrast to longitudinal, where there's multiple points over time, right, with longitudinal. So we could there look at changes and trends over time. But in that setting, in longitudinal, we're capturing data about subjects, and again, let's say people, but we're capturing information about them or from them at various points in time. For example, the census has a survey called the CPS, where people are surveyed in various months over time. So that would be an example of a longitudinal data set, right? Households are surveyed at multiple points in time. And then you can analyze that data to see, okay, for those specific people, did things change, right? Or those specific households, did things change? Obviously, the cost or resources is a lot higher for longitudinal. But the types of analyses that we can do is we can look at trends, we can look at causal relationships, and also do predictive analysis as well. Yeah, so hopefully it's really clear now. If, for example, I was doing a survey for cross-sectional, I would only capture information from a person once, right? So one time, whereas in longitudinal, I would want to capture or track someone over time. That's longitudinal is very common in educational settings, right? You might track a student and their progress over time, maybe as a result of some intervention or some educational program, and see the effectiveness of that. So those are the two sort of types that we can further define or understand in terms of whether or not we have cross-sectional or longitudinal data. With time series, so this is, you can think of as a subcategory of longitudinal. Obviously, we're tracking something over time, right? Tracking an event, an outcome over time. A common example here would be a stock price, right? Stock price goes up, it goes down. We can track the movements. You can see the Tesla ticker here and how it's gone up and down over time. Again, that would sort of show us that movement or that trend, if there is one. We'd be able to see that using time series data with those periodic values that are captured, and then we can even visualize that movement looking at a chart, right? So that's time series data. So once we understand now all the different data sources and the data types that we can analyze to address our business problem or business question, we can then move on to understanding variable types, right? So there's different variable types, and again, this is going to feed into the types of analyses that we can employ, the techniques we can use, and ultimately how well we can answer our business question or address our business problem. When we look at variable types, there's two main types: numerical and categorical, right? So numerical would be quantitative. These are measurable quantities. And there's two types under that. There's discrete and continuous. So discrete are actually whole numbers. For example, number of children, defects per batch in production. Those can be only whole numbers. 1, 2, 3, can't be 3.5. And then there's continuous, and for numerical variables that are continuous, that can be any value within a range, right? It might be height, it might be weight, temperature, for example. So height, you could be 5 foot, you can be 6 foot, but you can also be 5'1", 5'9", 5'11", and so on, right? And with the qualitative, though, these would represent categories or groups without a numerical value, right? So there's two types of qualitative or categorical variables. Nominal, order doesn't matter. So things like gender, colors, types of vehicles, those are categorical. They provide a description of what that observation corresponds to. But we can also have ordinal, and that's where there are categories, but the order actually matters, right? So even, for example, if we do a survey and there's satisfaction levels, right? Very dissatisfied to very satisfied, there's obviously, in-betweens, right? In between that, including neutral, right? But obviously the order would matter, right? I would want to know, for example, if someone's very satisfied with my product or service, that means that they're happy. If they're very dissatisfied, they're not happy about that product or service. And along those lines, if I think of business, if we go back to business context, for quantitative, for continuous, sales in dollars, right? That's a continuous variable. Discrete, I can think of as maybe number of employees or number of staff members. With qualitative, I think those are pretty clear, but nominal. Maybe I'm looking maybe at employees. I could, or customers, right? Customers, I might look at the if gender matters when I'm looking at preferences or sales outcomes. So you can see there that there's different variable types we're going to come across in addressing different business problems or different business questions. So you can see an example here. I just have some example data. There's 5 data points. And this is looking at house prices or property prices. And you can see the different fields there. So we look at the first 3, right? Property ID is a unique identifier for property. That's quantitative and discrete, right? It can only take on whole numbers. With city, that's categorical. You see New York, Los Angeles, and some other cities. Those are descriptions that in which order doesn't matter, right? So categorical, nominal. Number of bedrooms, that's discrete. We can only have whole number of bedrooms. And if we look at the other fields, up here we have price, right? We have price. That's quantitative and continuous. So similar to sales, right? The price could be, it could have some cents around it, right? 0.25 or some decimal value around the price. Has a garage, that's categorical. And this is an interesting description here. What we haven't really mentioned, or I haven't mentioned, dichotomous. Another way of saying that it's binary, right? It's binary. So that could be a categorical variable. Again, the order doesn't matter, but the 1, 0 or true, false. So we might see actually this coded in different data as either true, false, or a binary value, or Boolean value as a 1, 0, right? So 1 might be true and 0 might be false. You can see there's a condition that's ordinal, right? There's an order to something being fair, good, excellent, right? There's an order present. And then finally, lot size, that would be continuous, right? So the size of the lot, quantitative, continuous variable. Okay. So what's the punchline with this, right? Well, it turns out that analyzing data is a science, right? We have all these different data sources we can collect and analyze. It might be primary, it might be secondary. There's different types of analyses we can employ. But when we think about, going back to statistics, ultimately what we're trying to do is test a hypothesis. Right? Last module we looked at starting with a conjecture and then eventually developing a testable hypothesis. And to test that empirically, we need statistics. So you can kind of see here, this is actually on the left, there's a summary. This is put together by one of my colleagues, Bob Emmerich. And this is kind of like a tree, right? You can kind of see, okay, do I have categorical, quantitative? Okay, if I have one variable, what are the different things or types of analyses that I could do, both graphically and non-graphically? You can see that right there, when we look at relationships, some of the summaries that you can create there in brown. Obviously in the green, you can see that there's DV is dependent variable, IV is independent variable. And I could have quantitative, categorical, quantitative, and you could see the various types of analyses I can perform to be able to evaluate those relationships. But at the very bottom in orange, that corresponds to a statistical test, and that's where we're able to really test that relationship or test our hypothesis in a empirical way. So those are some sample tests that we can use. Ultimately, we're going to be able to use data to be able to do that. In fact, this is just a sample. It gets even more complex because many of these are what we call parametric tests. It means that there's some underlying assumptions about the data that need to be met before we can actually use them. For example, with the t-test, we are assuming the data is normally distributed. There's a way to evaluate that. But if it doesn't meet that criteria, there's actually what we call non-parametric tests, right? And there's basically no strong underlying assumptions about the data. So we call those non-parametric tests. And you'd see some of these tests, and if you use that resource to the right, there's a sort of flow chart that an individual put together to sort of help you decide, okay, do I have quantitative data as a categorical? What am I trying to look at? Is there underlying assumptions that I'm either meeting or not meeting? So we'll get into that more, but you can see that all this is related, right? Going from a conjecture to hypothesis to thinking about what type of data do we have, what can we test. It's all related, and that's the important takeaway from this module. So that would end Module 3.